Hello, this is Mrs. Boots, and we're going to work the practice problems for the change base lesson. Remember, the only reason we're changing base is so that we can use the log button in the calculator that's pre-programmed. It doesn't matter if we use log or if we use the ln button. Either way is acceptable. The base is always going to go to the bottom. The argument is always going to go to the top. Let's do some practice problems. Number 1, what's the base? The base is 3. So log 3 is going to be on the bottom. The argument is 5, so log 5 is on the top. I would plug that in a calculator, making sure I close the parenthesis. You don't have to have a TI-83 or 84. You can use a scientific calculator for this. Once you plug it in, you should get the answer 1.46. Now let's look at number 2. What's the base? The base is 6. So the 6 goes to the bottom, to the denominator. The argument is 50, so it's going on top. Now, remember to close your parenthesis. What does that equal? 2.18. Number 3, what's the base? The base is 3. Base goes to the bottom. I could use ln or I could use the log button, either one. The argument is 15, it goes on top. So log 15 divided by log 3, make sure you close your parenthesis, equals 2.46. Now let's look at number 4. Number 4 is not written as a log. It's written as an exponent. So we need to turn it into a log so that we can plug it in and find the correct solution. So what is the base? The base is 10. Well, log base 10 is just written as log. Then I have 200 equals to the exponent, x. Here's the cool part. It's already written with a base 10, so all I have to do is hit the log button and a 200. And I get the answer of x equals 2.3. Number 5. It's an exponential. X is in the exponent, so I'm going to turn it into a log. What's my base? 7. So I have log base 7 of 300 equals to x. Now the x is by itself, but we need to use change base to plug it in the calculator. Again, the base is 7, so the base goes to the bottom, or the denominator. So I'd have the log 300 divided by the log of 7. When I plug that into the calculator, making sure I close my parentheses, I get x is equal to 2.93. Let's look at number 6. Again, it's in an exponential form. I have to get my exponent alone by turning it into a log. The base is 5. So log base 5, go across the equal sign of 100 equals the exponent, x minus 6. We're going to have to do something with that x minus 6. But before we do, let's get a value for a log base 5 of 100. Remember, the base goes to the bottom. So I have log 100 divided by log 5 equal to x minus 6. Okay, plug in the logs into the calculator and get a value. I get 2.86. So 2.86 equals to x minus 6. How do we get x by itself? Yeah, this is just good old-fashioned add, subtract. We add that 6 to the other side, and we get x equals to 8.86. Number 7. The exponent part is not by itself. It has to be by itself in order to actually turn it into a log and solve. So I need to get rid of the 16. So I'm going to subtract 16 from both sides. Now I have negative 4 to the x equals negative 6. Well, we're going to change both of those to pluses. Now I can do my logs. Base is 4. So I have log base 4 of 6 equals to x. Log the base is not 10 or e, so we use change base. The base goes to the bottom, log 4. The argument is 6, it stays on top. Notice each one gets their own log. We're not just dividing the 6 by the 4, we're dividing the log of 6 by the log of 4. Okay, plug it into the calculator, what do we get? We get x is equal to 1.29. Number 8. It's not written as a log. X is in the exponent, so I have to turn it into a log to get x by itself. So I would write log, what's my base? 5 of 12 equals to the exponent, x. Okay, now let's do change base so we can plug it in the calculator. The base is 5. It goes to the bottom. The argument is 12. It stays on top. Log 12, close the parenthesis, divided by log 5 equals 1.54. Number 9. X is in the exponent. We have to turn it into a log in order to solve for the x. The base is 5. Log base 5. Go across the equal sign. The argument is 500 equals the exponent, x plus 2. Now let's use our change base to simplify the log to find its value. The base goes to the bottom, so log 5 is on the bottom. The argument is 500, it goes on top. Remember, each one gets its own log. I'm not just dividing 500 by 5. That's going to be equal to x plus 2. Let's find the value of 500, log 500 divided by 5. But then what are we going to do with the 2? We're going to subtract it. So we could plug it all into the calculator at once. Log 500 divided by log 5 minus 2. X equals what? X would equal 1.86. Let's look at number 10. Number 10 looks crazy. Well, it's not really. It just needs to be turned into a log. The base is 2. Log base 2. Of what? Yeah, the big long number with 6 zeros equals to the exponent, x. Now do change base. The base goes to the bottom, so the 2's on the bottom, millions on the top. Okay, so now I can plug it into the calculator. The log of a million divided by the log of 2. What do we get? 19.93. Number 11. Is the exponent part by itself? No. So we got to get rid of that 2 in the denominator. If a number is dividing, the opposite is multiply. So I'm going to multiply each side by 2. So I'm left with the 4x on the left. 4 to the x power on the left. And now 2 times 20 is 40. Now we can turn it into a log to get our exponent by itself. So I have log base 4 of 40 equals to x. Do the change base to plug it in the calculator. The 4 is the base, so the base goes to the bottom. So I have log 40 on top with log 4 in the denominator. Make sure you close the parenthesis. Log 40 divided by log 4 is 2.66. Number 12. Is the exponential part by itself? No. I have to get rid of the 5 out front. Remember that 5 is multiplying, So we can't just divide by 5. I'm sorry, we can't subtract 5. We are going to divide by 5. So on the left, I have 1.5 to the x power. On the right, once we divide 3,000 by 5, we have 600. Now we can turn it into a log. The base is 1.5. Go across the equal sign. The argument is 600. That equals to x. Okay, the base is not 10 or e, so we have to use change base. Remember, the base goes to the bottom, the argument goes on top. Make sure you close the parentheses. Log 600 divided by log 1.5 is equal to 15.78. Number 13. X is in the exponent. To get it by itself, I have to turn it into a log. My base is 8. So I write log base 8 of 75 equals to x minus 4. I have to do change base. So I have log 8 on the denominator because the base goes to the bottom and the 75 will stay on the top, log 75. Remember to close the parentheses. Now what are we going to do with that 4? We'll add that 4 to both sides. So once I do the log 75 divided by 8, log 8, I'm going to add 4. And I would get 6.08. Let's look at number 14. Is the exponential part by itself? No. So I have to get rid of whatever's over here, and that would be the 48. So I'm going to subtract 48 to both sides. We subtract because that 48 is positive. So now I have 2 to the x equals, negative 2 to the x equals negative 8. We can cancel out the negatives and make them both positive. Now we can turn it into a log. What's the base? The base is 2. So I have log base 2 of 8 equals to x. You may remember that one from mental math, but if you don't, it's okay. You can always use change base. So the base goes to the bottom. So the log 2 is on the bottom, log 8 is on the top. Make sure we close the parenthesis. So x equals 3. Number 15. Is the exponential part by itself? Remember, we want to get x by itself. That means this entire exponential part has to be alone. So I need to get rid of the 6 out front. We're not going to subtract it because it's multiplying. We need to divide both sides by 6. Now we have 1.2 to the x power equals to 3. Now I can turn it into a log to get the exponent by itself. My base is 1.2. So I have log of 1.2, log 1.2 of 3 equals to x. Change base. The 1.2 is the base, it goes to the bottom. 3 is the numerator. So log 3 divided by log 1.2. Make sure you close the parentheses. X is going to equal 6.03. Number 16. Well, we can already change it into an exponent. Our exponent into a log because there's nothing outside to deal with. What's the base? The base is 27. So I have log base 27 of 3 equals to 2x minus 1. Now I have to do change base. Remember, the base goes on the bottom. It doesn't matter if the base is bigger. It still goes to the bottom. So it's log 3 divided by log 27. That equals to 2x minus 1. What are we going to do with the minus 1? Yep, we're going to add the minus 1. And then, what will we do with the 2? Yes, we would divide by the 2. So we would divide both sides by 2. So in my calculator, I would punch in log 3, close the parenthesis, divided by log 27, enter, add 1, enter, divide it by 2. X would then equal 2/3 or 0.67. Number 17. X is in the exponent, turn it into a log. The base is 8. So I have log base 8 go across the equal sign of 2 equals the exponent, x plus 2. Now we have to do change base. So the base is 8, right? So log 2 is on top, log 8 is in the denominator. What do we do to get rid of the 2 when the x plus 2? You got it. We're going to subtract 2. We don't subtract 2 from the 8 or the log 2 on the other side. We subtract it from the quantity. So I have log of 2, close parenthesis, divide by log of 8, close parenthesis, minus 2. X would equal 0.33, which is 1/3. Number 18. The x is in the exponent, so I turn it into a log. What's the base? The base is 4. So log base 4, go across the equal sign of 8, is equal to 1 minus x. Little tricky, but not really. We still do change base. The base is in the bottom. So it's log 8 divided by log 4. Now what are we going to do with the 1 and the minus x? Well, the 1 would move to the other side with subtraction. So we know we're going to minus 1. But then we have to do something else. We have to get rid of that negative sign. So we're going to divide by a negative 1. Or you could say just change the sign. So I have log 8, close parenthesis, divided by log 4, close parenthesis, minus 1. And I get negative 0.5, which is negative half. Number 19. Okay, number 19 is just crazy easy, right? 3 to what power equals 27? Really? We did that problem. It's just a 3. So x equals 3. You didn't even have to turn it into a log. And if it's a whole number that you already know, you don't have to turn it into a log. Number 20 looks like a really tricky problem, but it actually is not. Did you know 8 to the 5th is a real number? Yeah, so let's actually just plug that in. So I have 4 to the x equals 32,768. It's a big number. If that were in your savings account, you'd be really happy. But we're going to take the log of it because we want the exponent by itself. So what's the base? The base is 4. So I have log base 4 of 32,768 equal to my exponent, which is x. Now we do change base. Remember, the argument goes on top, base goes to the bottom. So the log 4 is on the bottom, and the big number, 32,768, is on the top. Plug it into the calculator. We get x equals 7.5. This concludes all of our practice problems for change base.